Certain if that's working yet. And now I think I've got my voice. How about yours? All right.
Rebooting everything might be the solution.
All right. Yeah. Well,
It
fortunately,
is
I did
working.
find the right things to hit. Okay.
Okay.
Hey. All
Good.
right. Yep. So and now I just noticed I don't have the live stream window. Okay. Yeah. The live stream window is up. It's yeah.
Mhm.
And it's good. Okay. Good afternoon, Jan.
Good afternoon, Michael. Good afternoon. I just got some amazing new chapters in my mailbox.
Yes. Yes, indeed. Thank you
Nice.
for reviewing those.
Mm,
Yep. I am finishing up chapter 13
mm,
this next couple of weeks, and then I'll be going back through and doing all the revisions. So the technical editor or the technical reviewer, Sandra Mack,
mm.
he is up to chapter 7 right now. So he's got a lot of good feedback as well.
Mm.
So yeah, this is going to be a much better book for this.
Okay. Now there was still one thing which I'm still thinking about.
Uh-huh.
In a relay-based system, you send messages, and all the messages go through every node. Then in a CRDT system, the message goes to the first node, and afterward you replicate the state,
Mm-hmm.
not the messages.
Yes.
So the big advantage is that you don't have to send all the messages from the beginning to a new device
Nice.
but Jinaga is still sending all the messages. Because we do have the feeds, but if you don't use subscribe, you don't use any feeds,
Mm-hmm.
and you still want all the information, he will still send, when you load something, you get
Mm-hmm.
all the previous messages as well, all the predecessors. So you still get all
Yes.
the old messages or not?
Yes. So I actually do directly address this in chapter 12, but that's way deep into the book,
Okay.
and that's actually where most people are. Frankly, they're gonna stop reading earlier than that. Chapter 12 is really for the hardcore uh, tool builders.
Mm,
Chapter 3 even more so, or chapter 13. Yeah. So the the way that I address this is that in chapter 12 I'm talking about feeds. I'm talking about
mm,
how we can compute feeds from specifications, and then show some examples of not just if this was the specification, these are the feeds, but then also this is a real world scenario that you would find yourself in. You're using the delete pattern, you're using the period pattern, and you move from one period to the next, or you delete some entities. What
mm,
do the feeds then look like? Um, and there I show that things like deleted entities, all of the information about them, except for the fact that they were deleted, is no longer flowing down to the device because of the way that we built the feeds. With periods,
mm.
you're querying for the current and the n most recent periods, so you don't get the facts earlier than that.
Mm,
So that partially solves the problem that you're talking about. Doesn't fully
mm,
address it. There's the idea of mutable property, that in order to understand the current value of a mutable property, you have to understand all of its previous values. Um, and because of the mutable property pattern, there's nothing that the infrastructure could do to relieve you from that. You have to have that complete graph. It's the transitive closure. So um, so for that, uh, I basically advise that you try to keep your model as shallow as possible.
mm,
Don't overuse the mutable property pattern. For example, if you're keeping track of the state of an entity, don't make state a mutable property. Instead, have some workflow facts. Um,
Or if you
So
log GPS coordinates,
yeah,
don't
yeah,
use them as
yeah. Don't
yeah.
use the previous GPS coordinate as a
Mm,
predecessor. Just keep those flat. Yeah, um,
mm,
yeah. So yeah, there are ways to manage that, to control that, but yeah, at the end of it, you're correct in that the client is interested in more than the current state.
yeah.
It's interested in how it arrived at that current state. It's interested in um, the the part of the graph that contributes
Mm,
to its partial order. Yeah.
yeah. Because the beauty of a vector clock is that you just have the current state,
Mm-hmm.
but the beauty of historical modeling is that you have the current state with history.
Yeah.
So it would be sad to throw everything away. And I
Yeah.
think the fact that we have feeds solves a lot of the problems.
Mm-hmm. Yeah. And you mentioned in one of your feedback notes that the disadvantage of the vector clock is that you have to
Mm,
remember that device even if it's gone. It's still part of the vector. Yeah.
yeah, it keeps growing.
Yep. Yep. Very true. And yeah, the historical model knows absolutely nothing about the devices that it came across. So it scales to the number of devices, but uh, but yeah, you do have to work to control the scale with respect to the amount of data. Yep.
Mm. Because that's a problem that we see a lot in practical situations. You say, okay, it's a situation with 20 technicians, but the technicians, at a certain moment, they change telephone,
Mm-hmm.
so they create a new device, or simply they remove the application, they reinstalled it,
Mm-hmm.
and after a while you have 100, 500 devices, but only 20 of them are active. So if you keep carrying this in your vector clock, yeah, then the data that goes all the way over the wire every time increases.
Yeah. Yeah,
Uh,
that's true. Yeah. There's another pretty subtle advantage that I don't actually explicitly call out in the book, but it's the associative property um, that. Um, so when we talk about ACID 2.0, we're talking about we want communications that are associative, commutative, idempotent, and distributed. So that's the ACID 2.0 as opposed to atomic, consistent, isolated, and durable. Um, so the associative property is just like an addition that you can put parentheses around groups, and so like a plus b plus c, you put the parentheses around a plus b or around b plus c, and you'll get the same answer. Um, so in a distributed system, you can send a a, a, a batch of of facts of updates,
mm,
and you don't have to send them individually. You can batch them any way you want to, and you will always end up in a consistent state. Um, and so feeds give you a kind of a hidden batching mechanism, where in a lot of other protocols you do get messages one at a time. Like um,
mm,
uh, I mean, it's yeah. So I'm thinking about things like REST. So when you make a RESTful call, and you're going to post, or you're going to put, you're going to call one specific URL. You're going to send one small amount of data, and so you're like, I'm going to to create a new order. So I'm going to post to the orders endpoint, and I'm going to have the data that's all of the line items in my order. That's a nice chunk of data, but you can't call that endpoint and post multiple orders. And you also can't call an endpoint to post orders and also to update shipping information. It's those are completely different URLs. But but in an associative system, you can batch even those disparate things together and just send them all up.
mm,
So there's just one endpoint for save. There's just one endpoint for feeds, um, and so everything is just batched in those endpoints.
mhm.
So yeah, that's yeah, trade-offs.
Mm. Yeah, the when I was re-looking at that last episode that I didn't see about the chat app,
Mm-hmm.
I was thinking, well, there we go again with a timestamp to order the messages.
Yeah.
For a moment, I was thinking, why not just make it a predecessor? But
Mm-hmm. Yeah.
you just told me why,
Yeah,
because you get a
exactly.
very deep model.
Yep.
Um,
Yep. You do that too much, and then you end up with a blockchain, and
mm,
yeah, everything slows down.
yeah. So that's the trade-off between the timestamps and the predecessor successor
Yes.
relationship.
Yep. Yeah, and I actually do
All
hint
right.
at that a little bit in earlier in the book when I analyze chess. I say, well, there are two different ways you can model the chess game. Each move is the successor of the previous one, or you just flatten them out and give them an index.
Mm,
So I settled on the flat one.
okay. I saw a lot of messages coming in from GitHub, like
Yes.
versioning, and that's a very interesting topic.
Yes, yes, indeed. And yeah, I just barely got everything loaded up on this machine, so I'm gonna try some demos, and they're likely to fail, and
Mm,
that's what we do here. Um, yeah, but I got yeah. So in the video you just talked about, the terrible chat app, I was trying to iteratively improve the chat app, and I got to a
mm,
point where I was trying to add a field, and it just
yeah.
broke. It's like, bah. So I fixed that defect in Jinaga.JS last week. We haven't had a chance to look at it yet, but then this week I went through and I did the same thing in Jinaga.net. It's like, how does Jinaga.net respond to adding facts to predecessors? And in some cases, it responded slightly better, in that it
Mm,
just dropped those facts and it says, "Oh, I don't know how to deserialize these. I'll just ignore them." Um, yeah, I'm not certain if that's slightly better or not. But anyway, that's not the it didn't throw an exception. So you at least got the things that you could serialize, but that's still not that's not sufficient. Um, so yeah, this week I worked on the most important features for being able to version facts, and I still have a little ways to go. But yeah, so now we've got some versioning in Jinaga.net. So I think the way that I would like to try this out is, let's first see if we can return to the terrible chat app, and let's see. All right, I want to share, and then I want to transition. Right, and then there's the chat app. Oh, that wasn't the one that I want to transition to. That's the one I want to transition to. Okay, now you can see us both. Okay. All right, so where we left off, looking at this terrible chat app, it ran into an issue when we were trying to add some stuff to the model. So here's the chat model, and so I was adding a timestamp to the message, and it just told me that this is not a thing that I want you to do. So let's do npm run. What have we got? We have dev. That's run delete. Okay. npm run dev. Okay. So here's Vite. We open that in the browser. Okay. All right, so let's add the topic Jinaga. Boom. And I think this is where we saw lots of different problems in here. Why did it go to this layout. I like this layout. Okay, yeah, so the fact does not have a field named timestamp. So it just used the information that was in the fact, so, all the fields that were saved, and then when it's trying to project that into the current type, it's looking for a timestamp and not finding one. And if I look at where that ultimately comes from, it is going to be the message list view model right here. So that's the line of code that makes it look for a timestamp in the previously saved fact. So what I did in the latest version, so let me do an npm update Jinaga, which actually it's not going to do that because npm ls Jinaga, we are on version 5.7 and this was released in version 6. So I need to npm install Jinaga latest, which means I also need to npm, if I look at Jinaga server, actually this already showed me that right here. Oh, Jinaga React. Yeah, that's right. This one doesn't use Jinaga server. Jinaga React, we're on 4.1.1. So let's npm install Jinaga React latest. And now if I npm ls Jinaga, I see Jinaga 6.0, Jinaga React 5.01, because I always make a tiny mistake when I first do the .o release, so fix that. So now we've got the latest version here. So let's start that up again and see if it does a better job this time. Okay, so everything is up to date. Let's do Jinaga. Boom. And specify the type of the fact. And oh, wait a minute. I've run into this before. When I'm trying to dehydrate, I thought this was one of the problems that I fixed along the way. Okay. Well, there we go. There's the kind of demo that you get on Thursdays. Okay. So let's, just to make sure, npm run build, just in case we didn't pick up the appropriate changes. But I'm pretty sure it did. I'm pretty sure that there's still a lingering bug there. But the intent, I'll talk about the intent after we try this one more time. So make sure it's refreshed. Go to the Jinaga topic. Boom. Yeah, it's still there. Okay. The intent is that as it looks for any new fields that are not in the serialized fact, that it's going to give you back a, in the case of JavaScript, an undefined, because it doesn't know what type that field should be. So when we define the model here, we allowed undefined. And so that means that here in this view model, whenever I receive timestamp, I accept the fact that it can be undefined. And in fact, now I should be able to remove the cast. Because I did also fix the TypeScript error that was causing trouble there. So now it sees that timestamp undefined is just a field, so it just carries that type through. And so in fact, I shouldn't need Shouldn't need that. Yeah, it should be doing a much better job now of carrying types through. But timestamp here is allowed to be undefined, so this right here accepts undefined and does something interesting for my application in that case. So in this case, we will accept an empty string as the localized time. Otherwise, if it's a date, we localize it. If it's a string, we just give back that string. Which actually, I think, didn't I already talk about this on the last one? That's not correct. We really want to convert that to a date and then localize that date. Otherwise, we're going to get the ISO 8901 string. Or maybe I did that here. Yeah, I did that one here. So let's just try something real quick before we move on to .NET. What if I were to get rid of message timestamp here, so I don't really care about receiving the message. Now we're going to see the errors propagate. This doesn't have a timestamp, so we can't do that. And now message view model no longer fits the shape of the message view model type.
So sorting.
Yeah, so let's get rid of it there. Yeah, and so we can no longer do the sorting. So yeah, we just get rid of that there. Getting rid of everything. It's that. Okay, that's the reason that I wanted the ISO 9801 is because I'm using that for sorting. So that's the string that sorts. So doing that, it's still saying, yeah, it's still saying that I can't dehydrate. And we are talking about the message list view model. Interesting, 38. Okay. Well, definitely some stuff to fix there. But that's the intent, is that if you don't see the field that you're looking for, then return undefined in the case of JavaScript. In the case of .NET, we have some really interesting behaviors. So let me see if I can set this up real quick. So I've just done a build of a local package and brought that in. So using Jinaga.UnitTest and using Jinaga, I'm going to say Jinaga client is equal to Jinaga test. I think it's Jinaga test. It just hasn't run the using statements yet. So create. Let's try that out. Okay. So now I've got my Jinaga client. So I am going to set up a very small model. So let's just do a let's use the blog example. So I'm going to have a blog with 2 posts. So we will start with a fact type, and we're going to do blog.site. So this is a record site, string domain, and then we've got a blog post. So post is for a site, and we'll start with the title. So immediately we're making a mistake in the model. So if you use the title as part of the identity of the post, you can't change the title anymore. So that's a mistake. Now I'm going to go ahead and create a site. We'll call this michaelperry.net is equal to await Jinaga client.fact, and I'm going to create a new site for michaelperry.net, and then I'll have a post and so this will be a new post for the site michaelperry.net, and the title will be structural versioning. Okay, so we set that up, and I didn't bring in, let me go ahead and add GraphViz to this. That way we can do the whole render thing. So run all that. And then I can do GraphViz renderer render facts, and now we can have the post one. Okay. There's our little graph. Nice and simple. So now I want to let's start with doing a projection where we just get the titles of all the posts. So titles in site. That's going to be a oh, that's right. We have to define a model. Wait a minute. I'm mixing up Jinaga.JS and Jinaga.net. In .NET, you've got the type system. You don't need to define a model. Yeah. So titles in site is equal to given a site. I want to match that site and facts. Now we do some link. So we're going to do from post in facts of type post, or post dot site is equal to site. So that gives me all my posts, and then I'm just going to select post dot title. So that's going to give me a specification that turns a site into a collection of strings. And so now let's actually do that. So I'm going to say titles is equal to await Jinaga client query titles in site starting at the site michaelperry.net. And so show me the titles. And that's what we get. We get an array containing the string structural versioning. Okay. So far so good, but then I noticed my mistake. I say, that string was not supposed to be in the fact. It should have been in a successor. So let's go and fix the model. So now I take out the title, and instead I say date time created at, and so now if I do that, I've changed my model. So now this isn't going to work. Let's, in fact, skip over this one, because I really want to just jump straight to, we've got some new types, but we've got old data in the store. See, I created the Jinaga tests up here, and so it's got an in-memory store. I didn't rerun this, so that memory store still exists. So now if I try to do the titles in the site, first of all, it's not going to compile because that property no longer exists. So let's change this for a brief moment to be the created at insight, just so we can see what that would return. And so now here, cannot be inherited and inferred from usage. Why not? Created at is supposed to be, yeah, site, date, time. So this query, interesting. The query parameters, show me the parameters there. This is going to be the fact and the projection. Yeah, so the fact is, actually I think that's supposed to be the, yeah, that is just tfact. So given a site, give me a date time. Okay, cannot convert. Oh, okay. That's because that's what happened. This site, michaelperry.net, was created using the previous version of the model. So I do actually have to run this part, but let me just run that by itself. Okay, so now I've got this new one. So now, okay, I get back an array, and the, well, let me see, what is the length of that array? 0. Okay, that's not what I expected. What I expected was I would get the existing value. Okay, I think I know what happened. Yeah. Instead of date time, let's make this optional date time. Okay. Create that new one. And now, okay, now let it infer it, because that's supposed to now infer an optional date time. Optional date time. Boom. We still get back 0. Oh, okay. All right. So this this demo still needs some work too. But the intent. The intent is that we would get back our one existing post, and it would have a null created at. So this would give me back a list containing just the date time optional null. And instead it's filtering it out completely. That was the old behavior. I wonder if this build didn't pick up the correct changes. That might be what's going on. Let me just double check here. So that did a build. And I've got all my changes in there. Okay. Well, 2 demos fail, but that's fine. The important thing is that that we've got the intent out there. That what we're trying to do is provide reasonable defaults for all of the fields that do not exist in the existing model. So there are a few different ways in which this can manifest. So if I were to try it this way, and I'm selecting the posts and not the created at, then I would be getting back the fully realized facts. Let me Let me go back in time here, zoop, and update this one. So now I'm going to use date time now, so that let's do a run all. Make sure that you've got everything you need. Not implemented. Interesting. Okay, what if you're not optional? Okay. All right, so I don't have a test apparently for serializing an optional date time. I need to add that test. Okay, so now we run through this, we get a title, or this is actually now a post. Keep the names correct. So we get back one post. What I'm curious about is what is the type of that post. That is, oh, that's the type of the posts. I don't want the type of the posts. Let me get the type of the single post that's in that collection. And now this is, okay. We are looking at the old code because this is giving me back an actual post fact. Instead, it should be giving me back a post proxy. And that's the magic that makes all this happen. So I can dive into the code and show how post proxies are created. But yeah, let's first talk about what what it needs to be able to do in order to do this. So for one thing, it needs to be able to serialize this record type given the information that it had before. But that's there's a problem if you just take the information, like for example, if we had the title in here instead of created at, there's a problem with serializing that back into this shape. First of all, you have to drop the title, and then you have to make an assumption for the date time created at, and that would, the best that you could do is just the epoch. So that's going to be January 1st, 1970. Then if you were to have a successor to the post, so now you're going to have post title as a successor. So if you've got blog post title, and that's for this particular post, and it's got a value, and it's got post title array for prior. Oh goodness. So that that will depend upon the identity of the post. So when you create a post title and you put that post in there, it's going to turn that back into a fact graph in order to determine the identity of this post title. So it's going to re-serialize the post, but now it's going to serialize it with these fields instead of the fields that it used to have. And the identity of a fact is the collection of its type and its fields and predecessors. So that means it's going to compute a different identity. So that would definitely wreak havoc on your model. You're able to load the old model, but you're not able to add back to it. You try to, and then you create brand new facts, and that's not what you intended to do. So how do we fix that problem? Well, we fix that problem by, when we get back this post, we're not actually given a post record. We are given a derived class. We're given a post proxy. And that derived class captures inside of it the fact graph. So it knows what the identity of this post was. And so when you try to reserialize that back to a fact graph, it says, okay, already got it from this point forward. Here's the graph. Stop here. Don't reserialize the site. Just here's the whole graph. And so now you get this consistent behavior from one, being able to query these things to then being able to create successors, and you build onto the graph that the previous version started. So that's what that intent looks like. Maybe next time I will be able to demonstrate that intent actually working. Oh, okay. Yeah, I got this on the other screen. Yeah, this is how we actually accomplish that intent. This was a lot of fun to write. So let's go back to Jinaga, and we've got serialization. So in here we've got our emitter, and the emitter is the class that uses reflection in order to turn a fact graph into a bunch of records. So we've got this deserialized to type that is looking up a deserializer in a deserializer cache. And so if I go to that deserializer cache right here, I can see that we are using reflection in order to build up some lambda expressions. So I want to call this create objects with these parameters and turn that into an expression and send that along. So it's basically creating on the fly some code that is specific to deserializing a particular type. So in order to build that code, it's looking at all of the different parameters, creating a whole bunch of expressions for each one of those in order to get the values out of the fact parameter. So pass in a structure that just contains a list of parameters, and then this goes through one by one, pulls out the ones that it needs by name, and builds that graph. So what's really cool is that we can so that code was there before, but now it is instead of building the record type, it's building a proxy, and so it has to first create the proxy type on the fly. So let's jump down to create proxy type. So this is going to create something with the name of the type suffixed with proxy. It's going to create its own little assembly right here in memory just for this one type, and define that type in there. It's going to define a field called graph that's going to hold on to the fact graph, and then it's going to make that record type its base class. So now we've got a little property called graph, and so I've got my getter that will return the field, and that's going to be the get method of that property. So get down to emitting opcodes. You're just building some IL on the fly. This is cool stuff. So now that I've got a type that one more thing, it inherits from add interface implementation. It inherits from iFact proxy. So this builds on the fly something that will inherit from your record. It implements iFact proxy. It has its own little graph field, and then when you call its constructor, it's going to call that records base constructor. So take all of the properties and the predecessors of your record and pass them along, and builds that as a type in and of itself. So this where did it go? iFact proxy. That is just giving somebody access to the fact graph. And so when I go back and I serialize these things again, then I look to see, does it implement iFact proxy? And if it does, then just cast it and grab the graph there. Otherwise, continue on to do the serialization as you did before. So, yeah, this will stop that serialization once it sees something that it's received via j.query or Jinaga client.query or Jinaga client.watch. So it's something that was loaded from the database. It's like, okay, this is the same fact graph, so nothing has changed. It's the same identity. Otherwise, it'll serialize your brand new records that you created in your code into the right thing. And so, being that it inherits from your record type, the code that you have to write doesn't change. It's still the same kind of code.
Okay.
So that's fun stuff. Yeah, I'm not sure why I didn't package that code into the package, but we will try that out next time. Because by next time it'll actually be the published version. So we will be there.
But wouldn't it be interesting to have the possibility to switch it in to tolerance mode, where it adapts automatically, and a strict mode where it finds, where it alerts if there is if there are facts that it doesn't know?
Yeah. Yeah. So if we were to go down that route, let's turn that off real quick so we can chat. Okay. Yeah. So if we were to go down that route, and the developer chooses if they want to be tolerant or not, then I'm looking for the use case of not being tolerant, of shipping code that is strict.
No, just not shipping, just during development.
Oh, okay.
Just to avoid that, somewhere you misspelled a fact and it became a new fact, and he doesn't catch it.
I see. Okay, and so you change your record, and you keep developing, and so in that mode it would just ignore the one that doesn't match. Yeah. So that being the behavior that we just saw, which is the behavior of the currently released version. Yeah. Yeah. I'm trying to think. How would that look? What I'm really sensitive about is adding decisions that the developer has to make, and so therefore they need to understand why they're making that decision. Yeah, especially if this is one that you make during development mode. So you're first trying this thing out, you're going to run into this problem right off the bat, and then you're just going to make the change. And if the default is is tolerant, which I think is the correct default, then that means that you're exactly at the place of learning and exactly at the place where you would want to ignore the old data, but it's not ignoring it, and you have to figure out somehow to turn that option on.
Yeah, the question is when do you want to catch things, and when do you want to ignore them? Because once you are intentionally changing your model, of course you want to ignore it.
Yeah. Yeah, that is an interesting one. Okay. Yeah, so would that be something that you would want to be able to change globally? You're just like, I'm currently in this mode, so all queries, all watches will ignore. Or would you want to be able to do that on a specification by specification basis?
Yeah, if you would say I just want to test the software in basic mode, and you just start a fresh model, no old facts, then just a global switch would be useful. Just put it in strict mode, delete all your old data, start a program, create, and see whether it catches something.
Yeah. Okay, I can see putting something like that in. Yeah.
But then, yeah, if
On the other hand, I do like the idea of teaching people how to think historically right off the bat. One of my friends convinced me to add the mutable property pattern as a keyword to correspondence. So you could mark something as mutable, and behind the scenes it would implement mutable property, and then it would just make it appear as if it were a regular old property. People don't understand that, they don't want to learn that, just give them properties. So, all right, fine, and I give them properties. And then they didn't act like real properties because they, behind the scenes, could have multiple values, but they had to pretend as if they only had one. So yeah, in that case, now I've gone back and I said, nope, for Jinaga, you have to understand mutable properties in order to do this right. I'm going to say this, but then I've already violated this principle. So, I like the idea of forcing somebody to think through how would I version this as they're even making their changes, just locally. This pops up a lot in Entity Framework, for example. So you're working on your model, you create a migration, you deploy it to your local database, and it's like, oh nope, something worked, something wasn't right. You change things. So the correct way to do that in Entity Framework is to revert your migration, change the model, delete the migration, change the model, generate a new one, and so move all the way back, move all the way forward. And a lot of times on teams that have used Entity Framework on, people get into a situation in which that correct process doesn't work, and then they end up, it's either because they've committed something before they noticed the mistake, and now they have to go back and fix it, or it's because the down steps didn't apply correctly, and so now their database is in a bad state. So I always encourage people in those situations to pretend that you'd gone all the way to production with this. How would you really fix this problem? And often that means creating a migration that fixes the problem, rather than going back and editing an existing migration. Sometimes it even means creating a SQL script and sharing that with the operations folks, saying, run this on the production database and cross your fingers. So create that SQL script, check it into source code, share it with all of us developers, and we will deliberately put our databases in a bad state so that we can test this script. So that's the kind of behavior that I like to encourage on my teams. So in this case, I would like to encourage, even though people using Jinaga are not actually on my team, I wish they were, but encourage people to think about, if this were released to production and you had some data that was in this shape, how would you modify your model so that it tolerated that data and did the right thing? So that's the position I would like to take. Now, the place where I've already violated that is security. So I want people to think about security right off the bat, but I have set the default, if you have not set up any authorization or distribution rules, to be wide open. And I intend to gate that in the replicator as a service. So you can't publish a production replicator without having security rules turned on. But I didn't want to force people to learn security in order to just get started, just practice with stuff. So I set the default to a practice mode. So yeah, I've got those competing values.
It's not always easy to decide for other people.
Yeah. Yeah. Okay. Well, yeah, I will take a look at what that what that looks like. So, yeah, that should be a pretty easy top level switch to make. So on Jinaga client, maybe there will be a property, or maybe it'll be part of the create. That makes a lot more sense. You shouldn't be able to change it after you've created it. So part of maybe it's Jinaga test dot creates. Maybe it's both Jinaga test and Jinaga clients dot create. Yeah, and yeah, certainly Jinaga SQLite dot create. Yeah, definitely needs to be in there, because that means you've got data that's saved. Yeah, that's the most important one to have it in. So maybe it'll be just that one. I don't know. But yeah, a switch that you can set there to say ignore anything that doesn't exactly match the model.
Great. It's not easy.
Nope.
To have something that works all the time and that works well.
Yep. It takes large organizations to do that, and then even then sometimes they have their eye on a different ball, and they aren't looking at the one that other people think is important. And when enough people say, wait a minute, that's important, say, but why would you want to do that? Because that's what most people are doing. Stop looking over here, look at that. So yep. Hopefully we can keep Jinaga small enough that a small team can do all these things. But yeah, it's already gotten kind of big. I was going back through all of this deserialization code that I'd gotten working before, and I was like, wow, that does a lot.
It's a lot of code. It's a lot of code. Okay. Anyway, I'm gonna. I would like to start reading chapter 12 first, but I think I have to keep in order.
Yeah, it definitely builds up. Yeah, you can't get chapter 12 without. In fact, it refers back to so many chapters in there. It's just like, goodness, why is it referring back to so many chapters? Well, it needs to.
But I think to give good feedback, it's important to follow the chapters. So let's start with chapter 6 first.
Yeah, I think you'll like that one. That one was a lot of fun. Yeah.
Because that one is completely new.
Yes.
Okay.
Yep. That is describing what the world looks like once you've got immutable runtimes. It's like, we can do this, we can do this, we can do this. This is how it all comes together. This is what your data center is going to look like in the future.
Mm. Let's do that one first.
Yeah. Excellent. Well, yeah,
Okay.
hopefully next week we'll have a working demo in both JavaScript and .NET.
Okay. See you next week, Michael.
All right, see you then.
Okay. Bye-bye.
Bye.